Welcome back to our channel, Knowledge Spread by Sir Boots. And in this video, we're going to learn about one-to-one function, one-to-one function, and inverse function. One-to-one function is a function that satisfy the horizontal line test. If I will have a graph here, this is a Cartesian plane. This is x and this is y. And I will draw a graph here. And if we're going to draw a horizontal line in this line, it intersects at one point in the graph here. So this is an example of one-to-one function because it satisfies the horizontal line test. All functions satisfy the vertical line test. But only one-to-one function satisfies both horizontal and vertical line test. Let's go back to the graph I have presented to you. So if we are also going to draw a vertical line on the graph, crossing the graph, it intersects the graph at only one point. This graph satisfy both the horizontal and vertical line test, because horizontal line intersects the graph at only one point here, and the vertical line intersects the graph at only one point here. So this is one-to-one function. Okay, let me give you another illustration. Okay, another graph. This graph passes the horizontal line test because when we passes the vertical line test, because the vertical line drawn here passing through the graph intersects the graph at one point like here. But when we draw a horizontal line on the graph, it passes through 2 points, and therefore this does not satisfy the horizontal line test. And this is a function. This is a function, but not one-to-one. But not one-to-one function. Okay. So, these are illustrations of one-to-one function and not one-to-one function through the graph. Now, let's go to the table of one-to-one function. Supposing we have, for example, our one-to-one function is f of x equals 2x plus 1. Okay. Its graph, its table, we'll draw a table. Okay, x, y. So, we will assign values for x from -2, -1, 0, 1, 2. Okay, they can also have 3. Now, if we plug in 2 to the function, 2 times, plug in -2. 2 times -2 is -4, plus 1 is -3. If we plug in 1, -1 to x, we have 2 times -1 equals -2, plus 1 is -1. If we plug in 0, we have only 1. If we plug in 1, 2 times 1 equals 2, plus 1 equals 3. If we plug in 2, 2 times 2, 4, plus 1 is 5. If we plug in 3, 3 times 2 is 6, plus 1 equals 7. Okay. That is the table for this function. And the inverse of this function, the inverse, denoted by f -1 of x, that is the inverse of the function. The inverse of this function is has a table of this one, x, y. So the inverse is x is -3, -2, -1, -1. So -3, -2, -1, -1, 1, 0, 3, 1, 2, 5. Okay. 5, 2, and 7, 3. Okay, let's try. So, for 3, that is x, -2 is our y. For -1, -1. For 0, 1. For 3, x, y is 1. for x which is 5, y is 2, for x which is 7, y is 3. Okay. So, the domain of the function becomes the range of the inverse function. And the range of the function becomes the domain of the inverse function. It simply means, no? It simply means that to get the inverse f negative 1 of x of the function, we change y to x and x to y. So, and solve for y. And solve for y. Let's go back to the function. F of x equals 2x plus 1. Now, to get the inverse, change y to x and x to y. But f of x equals y. Therefore, y is equals to 2x plus 1. We change y to x and x to y plus 1. Then, solve for y. For me, I will use the commutative property. Commutative property means we have to transfer it in the other side, in the left side, and this one to the right side. Why? Because 2y will be here, no? Because we will solve for y. So this is how it is done. The commutative property is done like this. 2y plus 1 equals x. So interchange. But anyway, you can also solve this without using the commutative property. So solve for y. 2y equals x minus 1 by virtue of the addition property of equality. Meaning we have to jump, negative 1 will jump over the equal sign and change the sign to get into the other side. So we have 2y equals x minus 1, and there is a numerical coefficient of y, so we divide it by 2 and divide it by 2 so that it will be cancelled. 2 will be cancelled, and what remains is y y equals x minus 1 over 2. And since it is in the y is changed to x and x is changed to y, it's already an inverse function. So we have f minus 1 of x equals x minus 1 over 2. Okay. So we'll have this function. This is the inverse of this function. Okay. So this is the table of the inverse function. Let's try to plug in negative 3 here. So negative 3 minus 1 is negative 4. Divided by 2 is negative 2. So y is negative 2 here. We plug in negative 1. Negative 1 minus 1 is negative 2. Divided by 2 is negative 1. If we plug in 1, 1 minus 1 is 0. 0 divided by 2 is 0. If we plug in 3, 3 minus 1 is 2. Divided by 2 is 1. If we plug in 5, 5 minus 1 is 4. Divided by 2 is 2. If we plug in 7, 7 minus 1 is 6. Divided by 2 is 3. And so, this is the table of the inverse of the function, which is also a function. Okay. So, from this, we are now ready to solve or to find the inverse function using another example. Okay. Example. Find the inverse. Find the inverse of the function. Find the inverse function. No. Find the inverse function of the function if it exists. If it exists. So, y or f of x equals x squared minus 1. Okay. So, again, f of x equals y. So, copy the x squared minus 1. Change y to x and x to y. So, again, I will use the commutative property because y is here. So, I will change it here. If we use the commutative property, we'll only exchange the place of the terms. All the terms in the right side will be transferred to the left side, and all the terms in the left side will be transferred to the other side for convenience in solving. So we have y squared minus 1 equals x. We will not change the sign because we are just interchanging the places of the terms. So that is what we call commutative property. So we will solve for y. So y squared is equals to x plus 1. Okay. If it is y squared, we will not cancel the 2. But we will extract the square root of y squared. So we will extract the square root of y squared. Y squared is equals to x plus 1. So extract the square root. So square root of x plus 1. So we extract square root here. So we square root also here, the other side. So that we can cancel the square. So what remains is, so we will continue here, only y because cancelled square is already cancelled with the square root. So y is equals to the square root of x plus 1. But square root means plus or minus. So, there are two, for a value of x, one value of x, there are two values of y. Say for example, we have the table of x is 3, x, y. We'll have 3. So, if we plug in 3 here, 3 plus 1 is 4. So, the square root of 4 is 2. So, for 3, there are two y's, which is 2 and negative 2. That is the same 3. Therefore, it is no longer a function because there are two values of y for only one value of x. So, the inverse function of f of x equals x squared minus 1 does not exist. So, the inverse function does not exist. I would like to underscore that the inverse function does not exist. It means that there is an inverse of the function x squared minus 1, but not a function. So we get the inverse of the function f of x equals x squared minus 1, but the inverse of it is not a function. That's why the inverse function of f of x minus equals x squared minus 1 does not exist. Let's try another example. Okay. Another example. Find the inverse function of f of x equals 2x plus 1 over x minus 2. Okay. So, in this case, again, we have to change f of x to y equals 2x plus 1 over x minus 2. We change y to x and x to y plus 1 over x to y minus 2. Okay. In this case, we will not use the commutative property because we will cross multiply this one, y minus 2 to the x in the left side, no? We will multiply this one, x minus 2 to x in the left side, which is x times y minus 2, copy the terms in the numerator in the right side, so 2y plus 1. After that, we multiply x to both y and negative 2. So we have x times y is xy. Then x times negative 2 is negative 2x. Copy the 2y plus 1. After that, we'll group all terms with y as 1 in the left side. This one, xy, and 2y in the left side, using the addition property of equality. Meaning we jump over the equal sign here, and change 2y, transfer 2y to the left side, changing also its sign. So we have xy minus 2y equals this negative 2x, also by addition property of equality, we are also going to jump it over the equal sign to the other side, so that sign will also be changed. So positive 2x plus 1. After that, y is common. So we bring that out. We write a parenthesis. We bring out the y and write the remaining of the terms inside the parenthesis. What remains is x and minus 2. Okay. So y times x minus 2. Why, class? Because if you are going to distribute y to the terms in the parenthesis, that will still become xy minus 2y. Look, y times x is xy. Y times negative 2 is negative 2y. So just the same. So we factor out y here. Okay. Then copy the terms in the right side. Okay, after that, x minus 2 becomes the coefficient of y. And so we divide it by x minus 2. Divide the right side also with x minus 2. So it can now be cancelled because they're the same. The remaining is y is equal to 2x plus 1 over x minus 2. And this is the function obtained from exchanging y to x and x to y. That's why this is already a inverse function. Inverse function. So f negative 1 of x equals 2x plus 1 over x minus 2. Okay. So this is a function, and this is the inverse of the function. Why? Because if you are going to have a value of one value of x, there is only one particular value of y also. Supposing we are going to have values of for x, we have y. We'll make it bigger. No. Supposing f negative 1 of x, we will have a table x, y. Supposing we have x as 1. So plug in 1 here. 2 times 1 is 2 plus 1, 3. So 3, and this is 1 minus 2 is negative 1. So 3 divided by negative 1 is negative 3. Look, there is only one value for, in every one value of x, there is only one value for y. So say for example, we have 0 as x. So plug in 0 here, plug in 0 there. Here also. So what remains is 1 over negative 2, and therefore the y is negative 1/2. Look, so the inverse of the function f of x equals 2x plus 1 over x minus 2 exists. And this is the inverse of the function equals 2x plus 1 over x minus 2. Okay? So, one more example. Next video, I will give another examples. And this video just ends here. And thank you very much. Me, you will wait for another video that will be presented to you through the knowledge spread by Sir Boots. Thank you. Bye-bye.